Number 2, let f and g be functions defined by f of x equals log x, which I've highlighted in red, and g of x equals x4 plus 2x cubed, which I've highlighted in blue. The graphs of f and g are shown in the figure above, and they intersect at x equals -2, so right on the x-axis there, and at x equals b, where b is greater than 0. So b is unknown. Part A says, find the area of the region enclosed by the graphs of f and g. So the first thing that we want to do is graph the functions on the graphing calculator. We need to find the area in this region, so we need to know the integral bounds. So we know one of them is at x equals -2, so we need to find the right edge bound, which is b. So we need a graphing calculator to do this. So graphing these two functions on the graphing calculator, we're going to find the intersection of those two graphs, and though the intersection of those two graphs is going to be at b, and we'll see that b is equal to point, in this case I think it's 0.774. Okay, so that's the position of b. It's going to be at 0.774. Okay, and that looks reasonable. So once we've done that, we need to set up the integral for the area that's going to be enclosed. So to find the area, we're going to take the upper bound minus the lower bound to find the height of the rectangular pieces that we're going to calculate. So we need the upper bound minus the lower bound, and then we're going to multiply that by dx. So our integral is going to look like this. From -2 to positive 0.774. Okay, so this is our area, and that's going to be the upper bound, which is our log function. So log x plus 3, and then minus the lower bound, which is x4 plus 2x cubed, and then we're going to take that and multiply that by dx. Okay, we're going to multiply that by a thickness of dx, and then we're going to integrate that, and that's going to give us the area. So when we do that, we need to do this on our calculator because well, it'll be much easier. We could possibly do this on by hand, but it's going to be much easier by using the graphing calculator. So what I've done is I've just did the integral of the difference of those two, the two heights, and integrated as one, and I ended up with 3.603 as the answer. So in this case here, the area works out to be 3.063 units squared. Okay, and that's the answer. So it's 3.603. Okay, and that's the value of that integral, and again I did that all on the graphing calculator. For b, it says for -2 to b, let h be the vertical distance between the graphs of f and g. Is h increasing or decreasing at x equals 0.5? So that h value is just going to be the height between these two. That's going to be the same as h. So we're going to just take the difference, and we want to know, we're going to write the function h of x first. So h of x is going to be equal to log x plus 3 minus x4 plus 2x cubed. Okay, so that's going to be our h function. So we're going to find whether it's increasing or decreasing. Increasing or decreasing means the rate of change, or h prime. So we want h prime. So we're going to differentiate that function. We're going to get 1 over x plus 3 minus 4x cubed minus 6x squared. And then we're going to evaluate this derivative at -0.5. So when we plug in -0.5, I'm going to get 2.5 this is going to work out to be 1/2. Okay, we're going to end up with 4 over 8. And minus, this is going to be, so it's going to be negative 1/2 because of the negatives. And again, be very careful about these negatives when we're plugging them in. Here we're going to end up with positive 6 over 4. Okay, then I'm going to simplify that to 3 over 2. So when we work this out, this ends up being 2/5 plus 1/2 minus 1.5. That gives me negative 3/5. Okay, and that's units. And that's units per d per x. I'll just leave the units out. So the h prime value is negative. That means it is decreasing. So negative, therefore decreasing. Okay, so that h value is decreasing at that instant of x equals negative 0.5.